So we know what a function is. A function has its own execution context. In that execution context, you have a list of statements. So you're just creating a shopping list of statements of procedures that you want to run. And when you invoke that function, you are simply asking the compiler to get that execution context and start running those commands. Now, what is a conditional function? Well, instead of calling the function like you normally would, a conditional function relies on certain criteria and can execute different contexts depending on the criteria given and what we're checking for. Now, we're going to keep it real simple right here. If I have an if statement has an execution context, aka it has those opening and closing parentheses, and within those opening and closing parentheses, we write all of our commands. And if certain criteria has been met, that execution context will be triggered. It's a conditional function. It's not a function that we give a name and we call it and we pass it parameters. No, what we do with this conditional function is we simply define the criteria, and we define it in those brackets. So we first say if, then in the brackets, we add our criteria. So we want to compare values and so forth. And then if certain criteria has been met, it will invoke its execution context. Now, what's really powerful about conditional functions is the fact that you can actually chain execution context. So for example, if this condition fails, we can also have another execution context attached onto it. And what I can do is say else and then create a new execution context. Now, if the condition is not met, only if the condition is not met, it fails, and it doesn't trigger that execution context, then it goes to else, and it will run that execution context no matter what, because that execution context has no criteria associated with it. So we can actually chain, you don't have to, but you can chain execution context together. And we can go even further by going through multiple steps of criteria. This is called an else-if statement. So what we have is an if statement that will check a variable, and it will say, I want to see what's inside of that variable. And that variable contains, let's say, the account type. Let's say I have a back-end system where people log in and I need to check their account type. Well, if that's the case, I can say, go grab that variable and see if it equals head office. If it equals head office, it will trigger the execution context and it will deliver the head office backend, a special backend for the head office. Now let's also say we have another backend interface for accountants. So I need another set of criteria. It's going to deliver something different. We're not delivering the head office backend anymore. We're going to deliver the accountant's backend. Well, we say else if. Again, we are chaining another execution context, but again, we're checking for certain criteria again. So if head office fails, then it will check that variable to see if it contains the string accountant. If that variable contains the string accountant, it will trigger that execution context and return the accountant backend. Now, finally, let's say for everybody else that wants to log in to the system, no matter who they are and what desk they're behind, if they're not head office and if they're not an accountant, they get the standard backend. So then I can also put in an else execution context, and that will fire and it will say, okay, well, head office failed, account failed. So this individual is a normal account type, and return the normal backend, give them the normal login backend. So by having the ability to chain execution context together, it allows us to search for certain criteria, execute certain contexts, and have our application think through certain criteria. It allows our application to think. So I'm going to take a look at the JS directory. And in here again, I have a basic index.html file and also a JavaScript script.js file. Let's take a look at the script.js file, which contains a simple variable, and this variable contains an answer. So we're going to type this answer in and we're going to check to make sure it's the correct answer. So let's say I present a picture to the user of a cake, and I ask them the question, what is this picture of? Well, we know that the answer is going to be cake. So let's say the user chose the option of cake. Now what I want to do is create an if statement to make sure the user selected the correct answer. So this could be a multiple choice question, and so that could have multiple different values. So we need an if statement to check. So I first of all want to type in if. This will declare an if statement, and then I will open and close the brackets and open and close the parentheses. Now, just like with functions, when we're defining an execution context, JavaScript knows it is an execution context, and therefore we don't need to put the ending semicolon. Now what we need to do is type the condition within the brackets that will allow that execution context to trigger or not trigger. So what we need to do is first of all, go grab the user's answer. That's what we need to check. So the user's answer is contained within this box, within this variable. So I'm going to call this variable, which ultimately just contains the string cake. And then what I want to do is say equals, equals, equals. So now we have our triple equals comparison operator. So all of those comparison operators that I showed you in the last lecture are to do with your if statements. And now, again, it's case and type sensitive. So it must be a string type because we have a string type here, and it also must have the same character length, and it is case sensitive. So I need to check for if it says cake. Again, we don't want to put a capital C in here because it will basically say that this condition isn't true. So what we want to do is check to make sure this variable contains the string cake, and then this execution context will be triggered if this condition is met. So now what I want to do is go ahead and say, well, let's perhaps log something out to the console. Again, you could do console.log, or we could create a variable as well. So I'm going to create a variable, and we don't want to put in the var keyword because don't forget we have scoping here. This is an execution context. It has its own scope, and it's not going to be much use to us creating a variable that's going to be deleted. We want to create a global variable. So I'm going to ignore the var keyword, which means don't respect the scope. I need to give my global variable a name, so it's going to be score, but this isn't enough. This is a fetch command. We need a create command. So how do we change it? We put in the assignment operator, a single equal sign. And now we're assigning a value. So we're saying to JavaScript, if this variable doesn't exist, I want you to create this variable on the global scope. And now I can assign the value of 1. Now I'm going to save this, and we want to preview it in the browser. So let's go ahead and simply hit refresh. I'm going to open up the inspect window. Nothing is shown up because we didn't log anything out to the console. But however, if I type in score, you will notice that we do have a global variable called score with the value of 1 that came from this if statement. So we know that it was successful and check did go through okay. Also, you could, let's say, console.log and log out, correct? Your score is now, and then we can concatenate the score variable, like so. And again, I just want to pop in an ending semicolon. And if I was to hit refresh now, we get the console.log correct your score is now, and then the value of the variable, which is 1. And so there we go. That is a simple if statement. But what if they got the answer wrong? Well, I don't know who could get that answer wrong, but let's say they did and said it was a cherry. So now what I can do is write an else statement. Now we're chaining execution contexts together. So in this instance, the score is going to be 0. Now, if I was you and I was creating some application like this, you would have the score variable predefined. So I would already create that variable score up here and automatically give it the value of 0. And so that way I won't have to do it in the else statement. So it knows that I've already got this global variable. We're setting this global variable now because, again, this is either a create or set command. So at the moment, it's actually going to be a set command because it's not going to find that score variable. It's not going to find that box in that execution context. So it's going to go to the window scope and it's going to say, right, go grab that variable and take whatever's inside of that box, delete it, and give it the value of 1. Now what we want to do is say, well, I can say score is going to be equal to 0. Simple as that. And then you can simply log out some information to the console to say wrong. Your score is now score, and that will produce the value 0. Hit refresh. And now it wasn't a cherry. Wrong, your score is now 0. Now, I want you to take a look at the chaining of execution context. Now, if you have an if-else statement, what you have is 2 execution contexts that have been chained together. What's important to remember is the fact that in this statement, which is an if and an else, only one of these execution contexts will be invoked. That's a fact. So it's either going to say, well, execute the else context or execute this execution context if the condition is met. So if I say the answer that the user gave me was correct, what's going to happen here? Well, it's going to do the check and it's going to say this is actually true. At this point, it's only going to execute this execution context. All of the other execution contexts that have been linked together will be ignored. So think of it like a chain. We're chaining execution contexts together. There's 1 link and there's 2 links. Now we've already got to this execution context, the first one, and it is true in terms of the condition, and therefore it ignores the second link in our chain. So if I now go back and hit refresh, you'll notice only one of the execution contexts was invoked. Now let's say that I want to complicate things a bit more, and you will get sometimes questions that arise, is it one or the other? How do you write a question in programming to say, is it one or the other? Don't forget, what you are doing with your conditions is you are asking questions. Is something equal to something else? That's a question. Well, what if I say to you, what if something is that or something else? That's also a question. And what I want to do is say, well, I want to check the user's answer to see if it's either cake or cupcake. So now that I have cupcake, that's another acceptable answer. Now, regardless of whether the user has given me an answer of cake or cupcake, I want to run this code because technically I'm going to accept both answers. Now, I don't want to have to write this out again. I don't want to have to write another if statement to do this. Also, on top of that, that's repeating yourself. That's more code to maintain. That's not good. The correct way to program is the lazy way to program, which means you write less code wherever you possibly can. And in this case, you can actually do it. So I want to say, is this one type of answer or another type of answer? This is where we have the double vertical lines. Now, to get these vertical lines, hold down the Shift key on your Mac, and then there is a key near the return key. And then you want to go ahead and hold down the Shift key and press that key twice. If you're on a Windows computer, again, you want to hold down Shift on the left-hand side, and you will actually find that key hopefully somewhere around that bottom left-hand corner of your keyboard. Once you have done this, you have or. So that allows you to say, is this one or the other? So I can check for multiple conditions. So here I can write another check. So I'm going to say, go grab the box check again. I'm going to use the strict equals operator, and I want to say, is it equal to cupcake? And let's say the user has given me the answer of cupcake. What will this look like when the JIT compiler runs the code? Well, first of all, it's going to create the variables. Then it's going to take a look at this if statement, and it's going to say, well, I'm going to grab that box check, which equals cupcake. And does it equal cake? The answer is no. So this is actually failed. This is false. This is now switched off. Now, just because this is false, we're still not finished asking it questions. So it goes, oh, wait a minute, there's another question for me. Is it the other one? So we know that it is the other one. Check does equal cupcake. That's the value it's storing. So this is true. Now, because we have an or, it means one or the other, or the other, or the other. You can keep going in this fashion, by the way. It's not just limited to just these two questions. You could keep going and adding conditions. But in this case, it found true. And therefore, it says, okay, this is true. Check is equal to cupcake. So execute this context. And if I go ahead and save this now and refresh the browser, you will notice it's correct. It accepted the cupcake answer, and it will also accept the cake answer as well. Now we also have another one, which is and. So you only have or, so one or the other, or the other, or the other. So I could make another acceptable answer. So I could say, go target this variable again and say, I'll accept cookie cake as well as another answer. So now I have 3 accepted answers. And also, you don't have to refer to the same variable every time. These checks could be whatever you wanted them to be. So I could grab the score variable as well and say, is that equal to 0, for example, or 1, and so on and so forth. Again, these are just like you asking a question. Is it this? Or is this okay? Or is this okay? And so on and so forth. So that's what that means, or. But and is a completely different thing. You need to understand the big difference between or and. So with or, it means that what's on the left-hand side can be true, or what's on the right-hand side could be true. If one of them is true, it doesn't matter whether there is one that's false. If one of them is at least true, this execution context will be invoked. And means that whatever condition is on the left-hand side, such as this condition, and whatever condition is on the right-hand side, must both be true. So it's not one or the other this time, it's this and this. They come together, and they both must be true. Now, in this instance, this is impossible, because check cannot be equal to cake and also be equal to cupcake at the same time. That's impossible. You will always get this wrong. And this catches a lot of programmers out by not remembering or and the big, big difference there. Now, if I was to say, well, I want to check the score is equal to, let's say, 0, or I could even change the comparison operator to whatever I want it to be. Don't forget, this is a separate question. So it could be whatever question you'd like, but I'm just going to leave it like that for now. So I want to make sure that check is equal to cake and the score is equal to 0. If I hit refresh, you'll notice that both were correct. So check was equal to cake and score was equal to 0. So they were both true. Now, on top of that, let's say I change that to not equal to the value and type of 0. So score is equal to 0. And therefore, I'm saying I want to check to make sure that score isn't equal to 0. But because score is 0, this is false. And don't forget, with the ampersand, both sides must be true. So to the left-hand side and to the right-hand side, it both must be true. In this instance, it's not. One side is false. Score is actually equal to 0. So if I hit refresh, wrong. So go ahead and write some if statements with or and join me in the next lecture where we'll go ahead and complicate our example further.